What I want to share with you today is our ideas for thriving in the new normal, based on my experiences as CEO of a global company that engages tens of thousands of industrial companies from all over the world. While the human toll and the economic toll of this crisis has been terrible, the pandemic has also brought out some of the best in us too. We have pulled together on a massive scale to collectively reconfigure our daily lives for the greater good. We've seen incredible demonstrations of commitment and compassion in our frontline workforce. And we've seen incredible demonstrations of innovation and flexibility everywhere around us. In so many companies, digital has become the big hero that saved the day, leading many organizations to more deeply appreciate and even accelerate their digital transformation initiatives. Now that we've been forced into new ways of working, are we really ever going back? Today, I'm going to make the case that we not only cannot go back, but that we must forge ahead to a new digital-enabled normal that lasts long after COVID has passed. For industrial companies, the workplace, the workforce, and work methods are changing because of digital. What started as a forced experiment is settling in as a new reality. Mastering this new reality could become your greatest competitive advantage. Let's start by looking at the workforce. In most companies, baby boomers are now become a minority of the workforce, and millennials are taking over, and Generation Z is beginning to enter the picture. These workers are very different. They're digital natives, and they have very different ideas about what digital means and how to use it. When I pull out my Windows laptop at home, my 15-year-old daughter stares at it and says, "Dad, what is that thing?" She would never use a PC. She won't even think about using Facebook because it's so obsolete in her view. Many older workers fight against change, but these younger workers crave it. If they see a better digital solution, they embrace it quickly. This is actually becoming a problem for companies because many of the tools we use truly are dated. Your ERP system is 20 or 30 years old, and it looks that way. Based on the data I see, I believe the workforce of tomorrow that is in schools and universities has already moved on to newer digital paradigms. When they enter the workforce, I don't think they'll accept many of the digital tools we use today at work. Let's take a look at an example that's near and dear to PTC, which is the use of 3D CAD in STEM and engineering programs at high schools and universities. Traditional professional CAD systems all run on high-end workstations, which frankly students simply don't have. If you have high school or university-age children, you know what I'm talking about. They have MacBooks and Chromebooks and phones and tablets. Until now, students have been forced to do their CAD homework on school-supplied PCs in some on-campus computer room. When COVID shut the school or campus down, that all stopped dead in its tracks. The ability to work remotely on the student's Chromebook or MacBook or even their phone or tablet became the only path forward. Fortunately for PTC, a year ago, just before COVID struck, we acquired a software as a service or SaaS-based CAD system called Onshape. Because the application and all of the data lives in the cloud, a student can use any device at any location, even move between them. And the latest data and all of the functionality is always right there waiting for them. Plus, it's a multi-user system, so collaboration on a shared design is completely natural. The difference is stark, like the difference between Google Docs and Microsoft Word. Given the shutdowns of COVID, schools had no choice but to look for alternate solutions, and students were more than happy to switch to this newer approach. Adoption by schools and students has exploded, and I'm projecting that in a single year, nearly 50% of students will move to SaaS-based CAD, a technology that's used by less than 1% of commercial companies today. And these students don't plan to come back. Let's talk about how the same types of impacts are affecting companies today. The ability to free desk workers, or students, from their desk is just one of the 6 capabilities we now see as being key for thriving in the new normal. The others are frictionless, agile supply chains, connecting products and factories, bringing digital to the front line, enhancing our employee capability with AI or artificial intelligence, and finally, virtualizing everything with spatial computing. In the next 30 minutes or so, I'm going to take you on a tour that explains what each of these capabilities means and why they're becoming critical for industrial companies to thrive in the new normal. We'll start on this topic of freeing desk workers, but let's switch from students to corporate knowledge workers such as engineers. If you look at the global workforce, about 25% is comprised of knowledge workers like you and I. Knowledge workers are people who primarily work in front of a computer all day. They create value by exchanging information with other workers and with information systems. We all know that if you work on a computer most of the time, you can readily work from home. At least you should be able to, unless there's something special about the computer in the office. While cloud and SaaS-based tools have already transformed CRM, ERP, and many other enterprise software categories, the product development world has been lagging far behind for some good reasons. Our world is one of the few remaining categories of business software that remains largely on-premise. I've heard from numerous CIOs at global manufacturers that while the bulk of their knowledge workers transitioned to work from home rather seamlessly, many said their engineering organizations really struggled. The big, powerful workstations sitting on the engineer's desk at the office contain tremendous computing and graphics power, numerous different complex software applications, and a lot of data. Many have unique hardware and software configurations. Switching to a different home device is not easily done, and many engineers have been forced to use virtual desktop infrastructure to log into these powerful workstations from home, which is far from ideal. The solution is to apply that same approach that's now so widely accepted by students back to the commercial world. Let's take a look. All right, so I'm here with Adam in the office. He's sitting at a typical engineering workstation and looks like he's designing a turbo compressor to me. So like what happened at most companies around the world, let's say Adam was sent home. See you, Adam. But at home, he probably doesn't have a high-powered workstation, and he doesn't have any of the same software anyway. He's going to need to participate with his laptop or his MacBook, phone, or realistically any device that has a stable internet connection. Let's check in with Adam at home. So I'm here with Adam in his home. And as we can see, because the design data and the design software is all in the cloud, Adam's able to continue working on his design on his MacBook without being inhibited by the limitations of his hardware or his location. That's freedom. Now, while the ability to use any device at any time is a critical capability during the crisis, there are many other advantages for industrial companies going forward. Imagine no specific software installation being necessary for all those different designers and engineers and project managers to simultaneously collaborate on the same project at the same time. Let me show you. Adam's tasked with making a design modification, but he needs consultation from an engineering consultant, who just happens to be me, in order to verify that the changes meet the proper design specs. So I pull out my iPhone, and I can access the full functionality of the SaaS-based CAD system in order to make a small change. For example, I'm going to change a fillet and change the radius and confirm that, and I've made a change now, which you see reflected in Adam's design. Working from home is great, but that's the tip of the iceberg here. These powerful new product development capabilities lay the foundation for an agile, frictionless supply chain. Let me show you what I mean. When I refer to an agile and frictionless supply chain, I'm referring to the ability for partners on an impromptu basis to easily join forces to blend their ideas to design and manufacture new products. That represents a very different approach than what we've all known. Ask an automotive supplier how much they like having to maintain specific versions of CAD and PLM systems to work in different OEM supply chains. It's a real pain. Given the level of disruption of typical supply chains from natural disasters and then trade wars and now by the coronavirus pandemic, the ability to instantly collaborate without any infrastructure set up is a powerful capability to have. Let me share a few real examples of how SaaS technology has lubricated supply chain processes. The first example is one of impromptu innovation during an emergency response effort. When COVID-19 hit, the need for more ventilators came with it. The Francisco Gavidia University in El Salvador, in collaboration with local companies, wanted to help. They knew that any successful ventilator design would need to be producible with standard materials that are locally accessible. The initial prototype started inside the university facilities and evolved as they brought more industrial partners into the collaboration. This is the first design concept. Through testing, they iterated and changed form factors. Upon obtaining increased support from local industrial partners, the design evolved further, with many parts changing from 3D printing to metal construction to accommodate higher volume production. What this group of ad hoc collaborators produced here was amazing. This method of working together was forced by the pandemic, but nobody's going to forget the advantages for everyday business even when the pandemic passes. Some of you might be wondering if it could really be that easy for your product development organization to collaborate across the supply chain. To which I say, try it yourself right now. Just click on the link, just shared via chat, or else open a web browser and type in ptc.com/respirator. In about 15 seconds, you'll find yourself in a professional CAD system collaborating with the Francisco Gavidia team. Now you're in a read-only mode since they don't really want you to change the design. Nothing has to be set up in advance and nothing's left behind when you're done. That's what I mean by frictionless. In collaboration with our strategic partner Rockwell, we're finding many other agile supply chain opportunities. For example, in manufacturing engineering, where we can help factories reduce risk related to bringing up new production lines or making line changes and accelerate line optimization. We've seen we can reduce line commissioning and validation times by at least 50% and reduce operator training and validation times by up to 75%. It's a very strong value proposition. Usually deploying or modifying a production line involves collaborating with many different partners and suppliers across geographies to integrate data and coordinate all the needed changes. Partners can include machine builders, system integrators, and component or technology providers. Traditionally, all the different designs are delivered as zip files, representing a snapshot in time, using some type of file sharing solution like SharePoint or Dropbox. But what if you could gather each party and their data together in real time from all around the world and in the cloud with everybody collaborating early and often in the design process? Let's apply this concept to the construction of a new factory that Rockwell recently built in Milwaukee, Wisconsin. In this scenario, 2 engineers, one in Boston and the other in Tokyo, are collaborating in real time, incorporating their respective contributions in a multi-user session like you would do with Google Docs. It is clear in real time to each engineer what the other is doing. To help the automation engineers, we can capture all of the critical stop and start points in the assembly without having to go back later and make changes or create extra copies of the standard automation designs. Now that our machine design is beginning to take shape, we can start collaborating with the automation engineers in real time as well. Typically, automation testing can't start until the machine is built, which increases risk. But using Rockwell's Emulate 3D factory simulation technology, we can virtually test the functionality of the machine that we captured in the design. This allows automation engineers to test and optimize their control systems code in the digital world versus having to wait until the machine and subsequently the entire physical production line is built. On a different note that really highlights agile collaboration, I'd like to share a heartwarming story of the amazing innovation and collaboration shown by students in the FIRST Robotics Challenge. Now, you've probably heard of FIRST Robotics. It's a high school program designed to bring students, especially girls, into the field of engineering. FIRST is really a physical, face-to-face program, building physical robots, so it was shut down by COVID. The season was scrapped. But PTC swooped in with this Onshape SaaS technology and offered that students could work from home on any device in teams to build digital robots instead. There was no setup requirement. The students jumped right back in and the program immediately sprang back to life. Over the next 3 short weeks, more than 150 teams submitted digital robots to the competition. Robots that solve real-world problems, from identifying and repairing potholes on roads, to decontaminating medical equipment with UV lights, to cleaning and replenishing animal bedding in zoos to prevent spread of disease. Imagine 150 teams forming online and working virtually, starting from scratch and delivering results in 3 weeks. It's amazing. In the world that most companies live in today, it takes a long time to get the right infrastructure in place, the right versions of software installed at each company so that companies up and down a supply chain can collaborate. In the world that the next generation workforce is growing up in, it happens instantly. Adopting this new way of thinking can be a real competitive advantage. Let me show you an example. The next capability necessary to thrive in the new normal is remote monitoring of products and factories, which has allowed companies to continue to optimize operations despite work from home orders, travel bans, quarantine areas, and limited staff. Beyond the needs of the pandemic, IoT-enabled remote monitoring and remote service improves uptime in critical environments, saves massive amounts of technician labor and travel costs, and provides new ways to transform the relationship with your customer. The way companies manage customer relationships is actually being turned inside out. Rather than the historical practice of asking the customer to monitor the product they purchase from you and call if there's a problem, companies are now asking their products to supply a steady stream of telemetry data to help them better understand their customer and anticipate needs and problems. Using a product as a sensor on the customer's satisfaction and value, rather than vice versa, can ensure we never get that angry service call or that lost customer. ESAB, part of the Colfax company, is a US-based manufacturer of welding equipment and machinery, and a PTC customer who's enabled this kind of transformation with their products. The welder next to me is one of ESAB's arc welding products, typically found in the field at construction sites or in factories. It looks normal, but you see this WeldCloud logo on it. ESAB started a digital transformation with PTC and Microsoft a few years back that was aimed at transforming customer relationships and expanding their services business. Welding is a highly specialized and frequently regulated process requiring strict compliance with context-specific regulations and documentation practices. ESAB's WeldCloud IoT solution enables automated capture and reporting of weld session information, ensuring the highly skilled welder stays focused on welding rather than on documentation. WeldCloud provides ESAB with valuable data to get a better understanding of how their products are being used in the field, enabling ESAB to provide better service to their customers. In this dashboard, users can see the performance KPIs and usage and consumption information for a portion of their fleet of welders. This helps operations managers to plan and forecast the needed consumables and track production progress. The operation or compliance manager can drill down into individual sessions to review data points like time of each welding session, material consumed, setting and power usage of the welder unit, and trends over multiple welding sessions. The automatic generation of required reports is a huge advantage and time saver for ESAB's customers. The fleet manager gains visibility into the physical location of their welders and activity over time, as well as system configuration and events, which are now accessible in this dashboard. For companies that use these units in the field at construction sites, this is a great feature to manage logistics of unit usage at different locations or even to find lost equipment. By connecting their products, ESAB was able to transform their business and service model by providing real-time visibility into usage, performance, and compliance data back to their customers. And they can do it all from home. It's great to monitor and optimize equipment remotely, but what about all the workers who use it, like the welders, and the millions of other workers on the front lines? Their need is very different. For 75% of the global workforce, work involves interacting with and operating out in the real world. Frontline workers can't work from home because their work is in the physical world. You can't assemble an automobile from home, and you can't make a field service call from home. Knowledge workers do well at home because we have tools like Zoom or Teams for real-time collaboration, and PDF and web for publishing knowledge, and YouTube for capturing and sharing how-to knowledge. While knowledge workers marvel at the power of digital, frontline workers say, I sure wish digital would do something for me someday. But now there's a new approach with augmented reality that provides the frontline worker equivalent of those digital tools. Let me show you some examples in our factory. I'm standing next to a Volvo truck engine, and using this engine, I'd like to show the frontline AR equivalent to the YouTube, PDF, and Zoom tools that are so popular with knowledge workers. With 4,500 different engine variants in one plant, Volvo must ensure thorough quality control and needs to provide their frontline workers with the right digital tools to make that easier. Many companies turn to YouTube videos to train employees on everything from security compliance to work instructions. But YouTube can be confusing because it captures both the instructions and the background in the same video. I really just wanted the instructions because I wanted to use my own background. I like to think of it this way. Please don't bother telling me how you would inspect a somewhat similar engine in a different setting. Instead, tell me how I should inspect this engine right here, right now, in this setting. Using the Microsoft HoloLens 2 device, we're going to capture a procedure around how to assemble the fan motor to this bracket. To begin, we've asked one of our experienced frontline workers to perform this procedure while wearing the HoloLens. Because our expert's done this a number of times, he's going to share his insights and provide context to each step. This level of context is something you'd rarely find in documentation. Utilizing the HoloLens spatial awareness, the expert's going to place spatial anchors at key locations around this workspace. The goal is that later, a trainee will be able to literally follow in the expert's footsteps without the expert present. Once we've captured the procedure, we can annotate the captured videos and images quickly without needing expertise in any fancy video editing tools. The digitized expertise can then be viewed on a headset, tablets or mobile phones, or even published as documentation. Now let's watch as our trainee executes the same task wearing the headset to free up his hands. In his field of view, the trainee sees the spatial anchor associated with the first step thanks to the wayfinding arrows that guide him. Once he gets close to step one, he sees the associated videos and images captured by our expert become augmented into his field of view along with any additional content that was added. The trainee is then able to perform each step exactly as our expert did, all the while remaining hands-free. Keep in mind, it could be the case that at this point the expert is 2 years into retirement, so we're really immortalizing expertise by capturing it digitally. This concept is somewhat like YouTube how-to videos, but as you can see, it separates the foreground instructions from the background setting, so that for each subsequent use, the information can be reapplied again to the real-world environment. Capturing expertise is a powerful idea, but sometimes you need to publish more precise formal instructions, something you might typically do with PDF documents or web pages. But frontline workers would be far more productive if you could publish the information on the real world they're immersed in rather than on a document or computer screen that distracts them away from the real world. I like to think of it this way. If you want to publish instructions about this engine in front of me, please display the instructions on the engine, not in some paper document that distracts my attention away from the engine. For Volvo, quality inspections are rigorous tasks reserved for the most experienced technicians. Every operator must perform at least 40 different checks in just 8 minutes. For any discrepancy found, they document the reason code and then move on to the next step. Let's see what these instructions look like in augmented reality. The inspector is visually guided to each part that requires validation and can see a direct comparison of the digital expectation with the physical reality using an AR overlay and verify that the assembly is completed correctly, utilizing supplemental documentation to assist and provide additional context. In this operation, the inspector will use a smart connected tool to validate the torque of the preheater bolts. The tool downloads the target torque value, and the operator squeezes the trigger and sees the output and captures whether or not the step passes or fails the process. If an engineering change is processed that affects any configuration, the concept of a digital thread ensures the updates automatically flow back down to keep these published work instructions up to date and the inspection process accurate. As this work is conducted at multiple stations throughout the plant, supervisors can view the metrics from all connected work cells, giving the production managers a complete view of what's happening on their floor, allowing the quick identification of any bottlenecks that may be occurring. I've talked about capturing expertise and sharing it with frontline workers, and about publishing precise information to frontline workers. But what about all those moments where somebody says, hey, I need some help here? With AR, we can do something like Zoom or FaceTime, but you see the frontline environment rather than the face of the person. I like to think of it this way. If I have a problem with this engine, and you're the remote expert who can help, I want you looking at the problem on the engine, not at my face. Let's say I'm an operator in a factory, and I need to mount this bracket on the front of this engine. Unfortunately for me, the engine block has mounting holes for an older fan bracket as well. I'm not sure how to mount this, so I'm going to call my colleague, an expert, to consult with them. Hey, Mike, do you have a minute?
I do.
Hey, I'm looking at the front of this engine block, and there's a number of different holes in here. Can you tell me which of the holes I'm supposed to use for mounting this fan bracket?
Sure. Top left here, outside here, here, and here.
Okay, so it kind of goes like that, right?
Correct.
Okay, great. All right, thank you very much. Let me try that. Yeah, that seems like it's going to work. Great. Thanks a lot. I appreciate it.
Yeah, you're welcome.
Now, because this AR software has on-the-fly created a 3D model of the environment, the marks became attached to the model. And I could put my phone down if I wanted to assemble the fan mount, and then pick it back up, and the annotations would be anchored in the same spot on the engine that they were before. Now that the call has ended, I get a summary of the call with captured screenshots of any annotation that the expert and I created together. I can save these to create documentation that I might want to refer to again in the future. I trust you share my excitement for what augmented reality can do in terms of bringing the full power of digital to frontline workers. The challenges of the COVID pandemic caused thousands of employees to try AR for the first time. And having seen what it can do, I think they're never going back. Before we move on from this Volvo setup, I want to touch on the topic of artificial intelligence and the key role that it will play in the new normal. AI seems like a mystery to so many people. So I'd like to highlight in simple and practical ways how we see AI already enhancing our workforce, transforming our work methods, and digitizing our workplace. Behind the augmented reality experience I just shared with you is powerful AI-driven computer vision technology that allows the HoloLens, tablet, or phone to see and recognize the real world and then decorate it with valuable digital information. For example, to show the inspection steps for this engine or some configuration of it, we used a deep learning approach that trained against the matching CAD configuration to create a neural network that was downloaded and ran on the HoloLens, so the HoloLens knew precisely what it was looking for and how to accurately place and scale all of the digital information. This is really cool stuff. But AI can also be applied to many different product development work methods. AI can help an engineer make better designs, for example. Using AI-driven generative design capabilities, an engineer can quickly evaluate dozens or hundreds of computer-generated design options, each specifically optimized for different material or manufacturing methods. At Volvo, there's a constant goal to remove weight from the truck. So Volvo leveraged generative design within their CAD tool to see if they could come up with a better design to reduce the weight of components, such as this heavy engine bracket, without compromising any structural performance. Obviously, lighter vehicles can carry more cargo, they use less fuel, and they produce less tailpipe emissions. So it's a win all around. AI-driven generative design helped the engineer create this somewhat radical-looking design whose weight is reduced by about 50%, yet meets all the design requirements. Let's take a look at how this happened. Remember that our goal is to reduce the weight of this engine mount without compromising its performance. This is a critical part that's subjected to a lot of loads and stresses, so we're going to take advantage of the cloud and AI to generate several dozen different options representing different materials and manufacturing processes. So we begin by setting up the problem, identifying the space that the part needs to live within, the interfaces it needs to respect, and of course the loads that we expect to have on it. And now we're going to ask the software, given that and different materials and manufacturing processes, show us what you can come up with. And the software generates a lot of different options that get presented back to us. So the engineer gets presented with a palette of different options and selects what they feel is the preferred design. In this case, a design that's 50% lighter than the original design. Wow. A different type of AI also provides guidance to workers as they perform steps in their physical work processes. Another AI-based computer vision capability can track the hand motions of workers to see if what they do matches the documented procedure, to validate the task is being performed properly and optimally. Red indicates the motion was not correct, and green verifies proper steps were completed. It's that simple. In the course of my talk, I've talked about amazing technologies and how they contribute to the nature of work going forward. What if we took these ideas like 3D and SaaS and IoT and AR and AI and we put them all together into one big cohesive strategy? If we did that, we could virtualize an entire work site, including all of the assets and workers and processes that it contains. Not virtual reality like some make-believe video game, but truly virtualized reality, where from the comfort of your home office, you could virtually enter and walk around an active work site and see and monitor what's actually happening there and optimize the work of man and machine. This concept is what we call spatial computing. Let's take a look at spatial computing in action. As you can see, I'm actually being digitized along with everything around me. This is done through a process called volumetric capture. It allows you to see me live, not just as a video, but separately as a live 3D model that you could access from and navigate around in from anywhere in the world. You're not looking in through a window. You can be virtually here with me, moving around freely in this space. You could stand in front of me or behind me or even look down from above. As you can see, we can apply many types of analytics to such a model to track and understand what's happening, such as where I've been and what my human pose is as I go through my work motions. It's like a virtual sensor harness that I don't have to wear. Let's explore some of the powerful uses of this technology. Anna's using this same concept of spatial computing to program the movement path of the arm of this robot. Anna's creating a shared understanding between herself and the robot. Anna can see and modify the motion path using AR, which makes the bits and bytes of the digital definition visible to her in the form of sounds and sights. Thanks to IoT, the robot's getting the same information directly in the form of bits and bytes. When she's ready, Anna creates a start button and connects the start event to the first point on the motion path. And then when she hits start, the robot shows its understanding of what she wants by moving through the space per their mutual understanding. It's interesting to note that what Anna is doing here in the real world, you could be doing from home in the virtualized model of the real world I was showing you just a minute ago. You could program the motion of this robot exactly as Anna has done here in front of me. Let me show you another interesting demonstration of how we can use spatial computing. While collaboration and mutual understanding between man and machine is great, what if we brought more artificial intelligence into the mix to help optimize the work of both? Let me start by participating in a simple process. I'm going to take this container of lentils from the autonomous guided vehicle and dump it in the bin. Then I'm going to turn the machine on and allow it to meter out the correct amount for packaging. Now, if I were a real worker, I might repeat this step hundreds of times a day, 5 days a week. And there might be others near me doing the same. And there could be multiple shifts, and even multiple plants doing the same. How can we monitor and optimize this work? With this concept of spatial computing, we can digitize the entire process in a frontline work setting, such as a factory. Then we can use spatial analytics to analyze movement patterns, how much time the workers spend at specific workstations and tasks, and so forth. We can apply the scientific management principles of Frederick Taylor in broad and continuous way. In this example, we're creating virtual sensors that represent different steps in the process, such as pouring the lentils, starting the machine, emptying the bin, and so forth. We can capture each time these sensors are triggered to understand how the process varies over time. If you look at the timeline, we can see the waterfall showing the total amount of time spent doing different steps across the whole shift, or for each pass through the process. As you probably know, you can't improve what you can't measure. Under normal circumstances, this stuff's hard to measure. But suddenly we're measuring how products and people work together in processes in places like this lab. With this data, we can see the bottlenecks and find ways to eliminate them in a continuous improvement methodology that makes the process better and better. That completes my power tour of technologies that'll change the workforce, work methods, and workplaces of tomorrow. I hope I've helped shed light on how your organization can better survive and even thrive in the new normal, thanks to new capabilities such as freeing desk workers to collaborate from any device, anywhere, and with anyone in their ecosystem. Enabling an agile supply chain to enable collaboration with anybody who has good ideas without the massive friction that we're used to. Connecting products and factories to drive operational efficiencies and transform customer relationships. Bringing the augmented reality version of the digital tools we enjoy as desk workers to the frontline workforce. Enhancing our employees with the power of AI to optimize their work methods and designs. And planning for spatial computing to improve performance across all the dimensions of equipment, workers, process, and space. Let me wrap up. Necessity is the mother of invention. The COVID pandemic forced us to try new digital approaches. It opened our eyes, and we liked what we saw. Like a step function, the speed of digital innovation has never been faster. 5 years of digital innovation happened in 5 months because of necessity. Now it's time to take stock of what's worked and what didn't, and to think beyond just responding to an emergency toward business advantage going forward. Thank you.